All right, you welcome back to the class, dear colleagues, dear participants, and dear students. Like I said, I'm going to use that three adjective to qualify all of us. So you welcome back to the statistics class once again, and I call this class Independent Sample T-Test, a guide for researchers and statistics students. Of course, we have been working on these statistics, and we want to quickly work on these two today. And these two we want to work on, as we have seen, I'll just run you through the statistic of test of difference. Let me put it in that way, the test of difference. Like I said, there are basically three tests of difference. The t-test is there, the chi-square is there, and the analysis of variance. We have dealt with chi-square. And if you are just joining us for the first time, it's better you subscribe to this channel so that you get a notification anytime we have a video like this. And for those of us that are joining us, whatever grade level you are, try and make sure you help us to share, copy the link to this video, and make sure you share the link with your students so that anyone that is free now can join us virtually to enjoy this class. Because this class, we want to make sure that this class is as much as interactive class tonight, because we want to make sure that we carry almost everybody along in this class. We want to make sure we carry everyone along in this class so that no one is left behind in this class. So we want to quickly look at what we call t-test. As we all know, we have been working on it in our previous video, but we just have to pause to go back and look into the central tendency. So let's look at it now. When we talk about t-test, like I said, the other name for t-test is test for two sample means. I'll be showing us those formulas one after the other. When we look at it, there are different types of this formula. So what I'm going to do is that I'm going to display the formula on the screen for us to see. On the screen for us to see. So let me display the first one for us. When we look at this, I want to quickly explain this. There are basically three types of what we call t-test. There is independent t-test, and that is the formula there. And that is when we use to compare the means of two different groups. When you are comparing the mean of what? Two different groups. The second one is peer t-test. The peer t-test is used to compare the means of the same measure twice. And the third type is the one sample t-test. And as you can see the formula, it is used to compare the means of of a single group to a known value or a kind of a benchmark. So that's what I want to show you. So before we start into our questions. So before we start into our question. So you're welcome back to the screen. So let's see now how can this be. We can see the questions that we have on the screen here. The question is actually talking about, there are two questions here, and I want you to tell me whether it is independent t-test or a non-independent t-test. These questions you are seeing here is actually talking about a researcher that is investigating a gender difference in a student achievement test. They have conducted the test for them, and they want to find out if there is a gender difference in the student achievement test. So it got these values as obtained, and you want to look at it, whether there is a significant difference between the two. Of course, don't forget that the first thing to do is to first of all set your hypothesis. The first hypothesis, which is the non-hypothesis, and the other one, which is the alternative hypothesis. The non-hypothesis for this now, since the researcher is investigating the gender difference in the student achievement test. So that means the first one is to say there is no significant difference. Why the second one will say there is significant what? Difference. By the time we look at the two and our T calculated, that is whatever value we got here, is lesser. If it is lesser than the T table, that is the value we got on the T table, or we say the critical value. If it is lesser than this, that means we accept the null hypothesis. But if it is greater, that means this one will go for what? H naught. But if the calculated is greater than that of what? Than that of the value we got from the table, then we take the alternative what? Hypothesis. I hope that is clear, because I know this question has been generating different issues. Okay, at what point do you accept? At what point do you reject? So at a point where the value you calculate here is lesser than the value you check on the table, you take the null hypothesis. But if what you calculate here is more than what you check on the table, then you take the alternative hypothesis. So let's come back to this now. So as for this, some textbook may call this D. Some may call whatever name they call it. This is just talking about the difference in the mean of the word of the value. So the mean for this first one, if you look at it, this is the mean now. So the mean for the first one is 62.5 minus the mean for the second one. So this is so that means I'm taking male as my X1 and female as my what? X2. That is the first group, and this is the second group. So minus 61.6. Now let's take this away from each other now, and let's come back here now. This is just square root. So this one is like the questions we solved in our previous video. You see that in that place we were given variance, and that was the reason why we did not bother to square it. But because if you are given variance, there is no point for you to square it again, because the square of what? Of a variance is standard deviation. But if you are given a standard deviation, you have to square it. That's the difference between what we did in our past video, in our last video, and this present question. That's the difference between the two of them. So when we look at this now, so let's come back here now. So our S1 now, that is the standard what? That's the standard deviation for male. And that is what? That is 4.3. And you have to what? You have to square this. Everything to be divided by the sample. What is the sample for that male? That is what? That is 73. Plus, you move on to the second one, which is what? 4.5 all square to be divided by the sample, which is what? 75. So I want us to go ahead and do the calculation now. I want us to go ahead and do the calculation. So let's find the difference between the two. So the difference between these two now, that will give me 0.9. You can confirm that from your own too. As we said, this is a practical class, 62.5 minus 61.6. So that will give me 0.9 over. So come back here now and square your 4.3. 4.3 square. That will give me 18.49 to be divided by 73 plus 4.5 square. That will give me 20.25. Now, when you square this now, divided by what? 75. So let's take it here. That's 0.9 over square of what? So let's divide this one after the other. So when you divide 18.49 to be divided by 73, that will give me 0.25. That will give me 0.253. Then I'm going to add the second one, which is 20.25 to be divided by 75. And that will give me 0.2 what? 0.27. That'll give me 0.27. So if I add these two together now, so I'm going to have 0.9 over square of, so let me add the two together. That's 0.253 plus 0.27. And that'll give me 0.523. So square of 0.523, square root of 0.523. Yeah, so that will give me, this is 0.9 to be divided by 0.723. Let me take it to 3 decimal. So when I divide this now, so that will give me 0.9 divided by 0.723. And that will be equals to 1.245. 1.245. So that means my T calculated now is 1.245. Now, at this point now, I will need to go and check. At this point now, let me clean this, because at this point now, there is need for me to go and check my critical value. That is, I have to go and check my tables on the critical value. So this is my T. This is my T calculated. My T calculated is 1.245. So if I go on the table, where precisely am I going on the table? Before I can move on to the table, I have to get the degree of freedom. So the degree of freedom is the sample 1 plus sample 2 minus 2. So the sample 1 here is 73 plus sample 2, which is 75. That is male and female, minus 2. When you add 73 plus that will give me 148. Then let me take 2 away from there, and that will give me 140 what? 46. So that is my degree of freedom. So if my degree of freedom is that, if I go to my table and check under 0.05, if I check it under 0.05 now, 0.05 level of significance, my T table, let me put it T table like that. My T table now will be 1.96. Now between this now, I want to use another things to differentiate between these two for us, so that we see the difference between the two. So I want to use another thing to differentiate between these two now. Okay, so when you look at, this is what we check on the table. This is what we got when we do the calculation. Between 1.245 and 1.96, which one is the biggest? Fine, you said this is what? This is the biggest. That is 1.96 is the what? Is the biggest. So that means these are, that is our T calculated is lesser than what we check on the T table. It's lesser than what we check on the T table. And when it is like that, what do you do? What do you do? When it is like that, you take the null hypothesis. You remember at the beginning we said the null hypothesis says there is no significant difference between the word, between the gender of the word, the gender scores of the student. Why the alternative said there is significant what? Difference. So since this is lesser now, since what you calculate, the figure is lesser than what we check on the table, then therefore you take the null hypothesis, which says there is no what? There is no significant difference in the performance of the male and the what? And the female. You have just run that test. So that is that on that. So let's move on to the second one, which many people normally see as a big thing. And I want us to take this one by one. One by one. So I'm going to clean everything that we have here. I will take this again. The step is not that far than to look for the word, the numbers of 2 minus degree of freedom. The degree of freedom is just the sample 1. The sample of the first group is 73. Sample of the second group is 75. Then you take 2 away from that. That's 48. When you take 2 away, that will give us 146. And when you check 146 on the table, You may not see it up to that level, because when you go to your 4-figure table and you check it under 0.05, you are going to get 1.96. So 1 point, that is for your T distribution or your T table. So, and what we check there now, as you can see, 1.245 is lesser than 1.96, and therefore we take the null hypothesis, which is there is no significant difference in the performance of the male and the female. Are they being this is bigger? We'll take the alternative which says there is what?